Welcome to this explainer. All right, let's just dive right in. Look, if you've been working with JavaScript for a bit, you absolutely know how to build basic object literals. We've all been there. But today we're going to level up. We're looking at a super powerful, kind of behind-the-scenes hack that'll completely transform how you write scalable code. Yep, we are going to master the constructor function.
So to really wrap our heads around why this concept is just so essential, ask yourself, what if you needed to code 100 variations of a car? I mean, really think about that for a second. If you were stuck using standard JavaScript object literals, imagine the sheer pain, the absolute inefficiency of manually creating dozens or literally hundreds of slightly different car objects by hand. No way, right?
Because without a blueprint, your code turns into an absolute nightmare. We're talking a messy, cluttered wall of repeating code that's just going to haunt your dreams and destroy your deadlines. You start with my car, give it some properties, cool, but then you literally have to copy and paste that entire block of code down below to make my car too, manually going in to tweak the max speed and the driver. And then you do the exact same thing for my car 3. If your app needs 30, 50, or gosh, 100 variations of that car, this manual repetition is going to eat up a massive amount of room in your script, and it's a colossal waste of your time. It's just completely inefficient.
Section 1. Meet the constructor function.
Okay, so there absolutely has to be a quicker, more elegant way to handle all this dynamic object generation, right? Well, enter your ultimate savior for those cluttered scripts. A constructor function is essentially an object-creating blueprint. I kind of want you to frame this in your mind using a manufacturing metaphor. Just think of it as a master factory blueprint. Instead of handcrafting every single car from scratch over and over again, you build the factory assembly line just once, and from there, you just stamp out identical but fully customizable cars right on demand. It's really just a function that creates and initializes new objects for us.
And you know what's really interesting? You've actually probably used this exact concept before without even realizing it. Whenever you type new array, you are literally calling the built-in array constructor function to spawn a brand new blank array object. Same exact story when you write new string. So really, there's absolutely nothing stopping us from hacking this built-in JavaScript superpower and applying it straight to our own custom objects.
Section 2. Assembling the blueprint.
All right, let's actually build our own custom constructor line by line and totally demystify the syntax so you can start using it today. Break it down into 3 core rules. Step 1. You set up a variable to store the function, and this is crucial, you capitalize the function name, like car with a capital C. Generally speaking, that's the standard JavaScript convention, so other devs instantly know, that's a constructor. Step 2. Inside the parentheses, we pass in variables like max speed and driver. These are just placeholders for the unique details we're going to feed into each specific object later on. And step 3, we bring in the all-important this keyword.
So let's look a bit closer at the cause and effect that this keyword, because it's a real game changer. Back in the day, the old manual way, we had to hardcode stuff like mycar2.maxspeed equals 50. Painful, right? But with our dynamic blueprint approach, we just write this.maxspeed equals max speed. In this specific context, the this keyword represents the new object that is currently being created. It effectively owns the space. It dynamically grabs whatever value you pass into the function and snaps it directly onto that specific object's property.
Section 3. Attaching reusable methods.
Now keep in mind, these blueprints aren't just for setting up boring static data. We can attach logical methods too. Things like a drive function or a log driver function, right directly to the blueprint using that exact same this syntax. So by defining this.drive equals functionality, we guarantee that every single car spawn from this blueprint comes equipped with immediate built-in access to that exact same functionality. Boom! We never have to copy and rewrite those functions ever again.
Section 4. Creating scalable instances.
Okay, so we've built our blueprint, we've attached our methods, now let's shift gears and actually put this blueprint onto the factory assembly line to stamp out some cars. To generate an actual usable object, we rely heavily on the new keyword. Take a look at this. var mycar equals new car 70 ninja. This right here, this is where the magic happens. By calling new right next to our constructor function, those unique variables, 70 for the speed and the string ninja for the driver, get passed straight into the function. It instantly generates a completely distinct, unique object mapped to those exact values.
And this brilliantly illustrates the massive scale and efficiency we've just unlocked. With a single, super simple function call, we can endlessly spawn entirely unique objects.
My car gets us our driver ninja going 70. How about my car 2? We just pass in Humpty Dumpty and 50. For my car 3, we pass in James Bond and a speed of 100. We literally only had to write the underlying constructor function once, but we just efficiently built out all these distinct variations in mere seconds.
Let's actually verify this in the console, just to prove how flawlessly the whole shebang works. When we call mycar.drive30, 5, meaning 30 miles per hour for 5 hours, the math executes beautifully, right from the blueprint, and returns a distance of 150 miles. Awesome. Then, when we call mycar3.logDriver, the console correctly spits out the specific driver name as James Bond. Testing these instances perfectly returns the unique, correct data for each individual car, every single time.
So let's take a quick step back and summarize exactly what we've learned here. Before, we had a workflow that resulted in 100 manually typed objects just completely cluttering up the script. It was repetitive, it was rigid, but after applying this, we have one clean, scalable blueprint that can seamlessly trigger 100 dynamic calls. I mean, it is an incredibly elegant JavaScript architecture that'll completely transform your workflow and efficiency.
Which brings me to this final thought I want to leave you with today. Just how many lines of code can a blueprint save you today? Seriously, as someone actively building things, I highly encourage you to immediately go audit your current scripts, track down those messy, repetitive object literals, and apply this powerful time-saving technique. Master the constructor function and just watch your code become cleaner, leaner, and vastly more scalable. Thanks for joining me on this explainer, and hey, keep on building.